Our projector controller's here. I'm going to set to this blue color because we're actually going to extrapolate these out again to another level of detail, because this is going to be the most complex part of the program and I want to understand what it's going to look like. So our projector calibrator is going to consist of something that allows us to position, so our virtual projectors. So that gets us the position and rotation of our projectors. We're actually going to need the camera and light to act as projector again. Remember, one sees the dome and the other projects back onto the dome. We are then going to need that rendered output. And then finally, we will send it into a pixel mapping toolkit. So this will connect into there. So our virtual projector controller will set where our camera and light is. The rendered output from that camera will then give us a representation of what the projector should show. And then we'll allow manipulation of that by sending it into the projection mapping toolkit. And all of that will be output to the main projector outside of this container. Virtual projector controller is going to require an extra level of detail, as is our projection mapping toolkit, which is going to have 5 different elements that make it up. Our virtual projector controller is going to be made up of something that allows the user to input the projector's throw. So one of the most important things is correctly understanding what the throw ratio of our projector is, so that we can capture the dome surface accurately. The next is going to be something that allows user control for position and rotation. So when we know that it's able to capture the right amount of data, we need to be able to put it in the right place and see the right thing. And then this is going to give us a calculated projector matrix. So these combine, 2 user inputs combine to give us data about the projector that we can use to accurately make fake or virtual ones inside of our scene. And again, the data is going to come out of this projector controller into our projectors. The mapping toolkit is going to consist of something that allows us to keystone the corners of our projector. So this is going to be like a standard stoner setup, if you've used one before. So something that allows us to control the corners of the projector. We're then going to have our pixel mapper that's going to have about 3 levels of detail. So we're going to allow the users to control multiple amounts of pixels using multiple stages of mapping. And then finally, we need something that can apply an edge mask to our projectors so that we can blend them properly. And all of these things are built from the same core component, which is a grid of warpable pixels. So I'm going to suggest that our pixel mapper is the most complicated and bring that down into a final level of extrapolation. So if I align left top, this is going to be the most complicated part of this entire build, and it's probably going to take up the bulk of the video as well. So the way that a pixel mapper works is that we have a high density grid. We then have a low density grid, and we apply these on top of each other. So the high density grid maintains smooth translation between pixels. And because we don't want to say control 8,000 points, we use a lower density grid on the top of a high density grid that allows us to manage our warping much easier. So our user really only controls 10 points, but they're actually manipulating hundreds of pixel groups underneath. So I'm going to center that. So our control point is essentially a transformed grid. So our control points are going to give us a transformed high density grid. And to that, we are going to apply our rendered projector image. So we're going to take our rendered output into here and apply it to that warped grid. This grid is going to be the exact same size and aspect ratio as that texture. So any warping that we do is going to be an accurate adjustment on whatever is output. We then use a special orthographic camera setup to capture our grid. So again, this isn't going to be a physical link, so I'll turn this into a dotted line. And then we output, and then we can output our warped projection texture. And this is a physical link. So this is what leaves the scene and goes on to go into our, well, technically our edge masker, but after that it goes to be projected into the real projector. One part we're missing is that there is some manipulation from the user required on this low density grid. So I'm going to input a visual editor. We're going to need some sort of UI for the user to be able to actually control what they're looking at. And that UI is going to give us user controls grid point positions. So that would plug into there, and that would then plug into here. So the user will see a version of the grid. So we need some sort of, so our grid points are given some sort of virtual representation in a 3D world. Those grid points then are shown to the user in some sort of virtual editor. And in a feedback loop, the user is able to move the virtual representation of the grid points, which actually updates the real grid underneath it. And that real grid is controlling a super high density grid that is then warping. And after that, then this is the main bulk of what our Touchdesigner network is going to be like. This is quite extracted right now, so it's fairly high level. But as we go through our development, we'll keep referring back to this and adding elements and using it as a reference to guide whether we have or haven't done the tasks that we think we need to be able to achieve this project. So I'll leave this there for now, and I hope you recreate some version of your own. I'll try and share a link to the PDF for this so that you can have it as a reference if you don't want to make one.